Hello everyone, welcome to KnowHow webinars. This is an online platform for professional education and it is managed by TechnoBiz. Today, I would like to introduce our expert. We call program called Meet KnowHow Webinar Expert. And through this program, objective is we would like to introduce our expert, what they're good at it, and what kind of experience they have, what kind of topics they're presenting. That's now whole object of the Meet KnowHow Webinar Expert, so that you get more information and confidence on the subjects available from the KnowHow webinars. We are here today. Mr. Terry Chapin is a rubber technologist based from the USA. Let me quickly brief about Terry. He is a rubber technologist and currently at the Elastomister doing the rubber consulting, training, and teaching. He has worked as a senior materials engineer working with elastomer and foam materials, senior rubber technical and cost leader, and a tool engineer for rubber and plastic molds. He holds 2 US patents and has been involved in the rubber industry for 40 years, working with rubber companies globally. Terry has been active technical speaker for the university level continuing education, instruction, rubber conferences, and technical implant venues for 30 years. See, this is briefly what I'm saying about Terry, but I will learn more about Terry through this program. What he has close to 40 years experience. In this 40 years experience, what he has learned, some of the suggestions for the industry. I think it's a very good program for all of us to follow. And I just give you quickly introduce about the topics that he has presented for the KnowHow webinars. And these are the list of the topics. He'll be describing each and every topic, what's about and who benefits out of this one, what are the contents in there. And so let's go in details one by one. Okay. And this one also, he has a master class. He'll be adding more topics in the near future. These are currently what topics are available. Let's get to know Terry Chapin. Terry, let's get started. Welcome you to this program. I'm the Meet KnowHow Webinar Expert. And can you talk about, first of all, let us please introduce your company, what you're doing currently, what kind of activities. So yeah, please, it's all to you now, Terry.
All right, thank you, Param. Hello, everybody. As Param had mentioned, after working for almost 40 years in the rubber industry, I decided that it was time to start out on my own as a rubber trainer, consultant, and educator because of the fact that I have a large amount of experience in the rubber industry. My previous jobs allowed me to travel globally. I've seen a lot of different ways of making rubber parts. So with that in mind, I decided to go ahead and start my own company called Elastomister. And my title, as Param had mentioned, is rubber technologist. I'm also the president, the secretary, the treasurer, the chief bottle washer. But basically, it is me working with companies like TechnoBiz, sharing my expertise. I've enjoyed the training and teaching aspect of the job and decided that this was something that I could do to finish my productive years in the rubber industry. So with that, I started my company Elastomister, which was a nickname given to me by some component engineers I was working with, which is, it's not German, but it's German sounding, and it just basically means rubber master or rubber expert. So, and that was a name that I felt would work for my company just as well as any other name.
Thank you, Terry. Can you talk, you got 40 years experience. Can you tell us about your past experience, where you started, since when, which company, what kind of roles you played, what kind of experience you gained? Yeah. Thank you.
Certainly. I actually got my bachelor's degree in mechanical engineering from Youngstown State University in Youngstown, Ohio, in the United States. As Param had mentioned, I'm based out of the US, although that certainly doesn't mean that I cannot or will not travel. I've been in 25 or 26 different countries through the course of my experiences. And as I had mentioned a little bit earlier, I've seen a lot of different ways of making rubber parts. even when I started in my career, I started as a hydraulic cylinder engineer. And while I wasn't working with rubber parts directly, I was still working with rubber parts indirectly because we had rubber seals in those cylinders. So I was already getting exposure to the rubber industry, even though I was not involved at that point in time as far as making, or actually producing rubber parts. And then that carried on into my second job as a project engineer at a company that was making loading arms. And then my real career started in rubber when I became a tool engineer for rubber molded parts at a company. At that time, it was the Packard Electric division of General Motors that later spun off and became part of Delphi. And now it is, the company is now called Aptiv. But I started there as a tool engineer, designing, building, debugging, putting into production rubber molds, working with our materials engineers and process engineers for the design, debug, and putting into production. Basically a cradle to grave. And from there, I started as a technical consultant, technical lead or technical consultant for the Delphi Rubber Global rubber team, and supported purchasing, supplier quality, as well as component engineering, as far as product design and helping with troubleshooting. And then after that, I also became involved with cost management and became a cost leader for rubber parts, helping our buyers determine what was a fair price to pay for rubber parts. And after that, ended, I became a materials engineer working with rubber, foam rubber, as well as liquid silicone rubber, and polyurethane materials. So I've actually been involved with several different types of rubber types of products, seen a lot of different rubber products being made, and worked with a lot of different types of rubber parts for various rubber applications. As Param had mentioned, I've been a speaker for various continuing education classes for the University of Wisconsin-Milwaukee, the University of Akron, their Polymer Technology Services Division. I've presented papers for the International Elastomer Conference, or the Rubber Expo, as it used to be called, and as well as for TechnoBiz.
Terry, I think you also have a number of patents registered on your name. Can you talk more about the patents that you have registered and what kind of innovations you developed over the years? Yeah, thank you.
Well, I do have 2 patents, and even though I've never been a component engineer, as I had mentioned a little bit earlier, I have worked with, component engineers, and it primarily is making the parts more manufacturable. The first patent that I received, literally me and a couple of engineers were having lunch together, and the guy said, "Hey, I've got this idea." And he sketched it on the napkin. I mean, we're literally talking, it started from a napkin sketch at lunchtime. And, the concept he had was not manufacturable as he had designed it. So I made some recommendations so that it could be molded by either by our in-house molding facility or by one of our outside suppliers. And he felt that I had made a significant enough input into the design that he did include me on the patent for that particular product. And that is for basically it's a snap onto the spark plug. You just push it, and it snaps and engages right to the spark plug. And then my second patent was working with another component engineer, looking at ways to reduce the engage force. And we came up with some surface finishes and some geometries that allowed the grommet to be installed with less insertion force and help the ergonomics for the installation for that particular type of product. And that patent has been used on several additional designs going forward, for similar types of parts.
Great, great. You have been in the rubber molding industry for so long. What's current trends in the rubber molding businesses now?
Well, certainly one of the things that is changing the landscape of the rubber industry is the mergers and acquisitions that we're seeing today. The large rubber companies seem to be getting larger by buying other large rubber companies, or just buying smaller companies and continuing to grow. That's going to change the amount of companies that are available to mold certain types of parts, as well as the availability of the raw materials, as the raw material suppliers are also merging and acquisitions within the raw material industry. I think the nanotechnology has some very good opportunities to get us to the next level for rubber types of parts. I have some concerns about the amount of rubber trees that are currently being planted, and the amount of active rubber plantations. Right now, the price of natural rubber doesn't look too bad, but there've been some dips in the pricing that have discouraged the plantations and rubber farmers from planting rubber trees. So I think that's going to make the natural rubber a little bit more scarce. A couple of things that are helping is the development of things like using the dandelion or the whale latex as an alternative for natural rubber. Some additional things that I'm seeing happening is, as cars continue to get smaller and they continue to, the engine compartments tend to be smaller and more things put into the engine compartment, your under hood temperatures are continuing to increase. And some of our traditional materials, let's just say like natural rubber for vibration dampening, no longer will survive in those types of environments. I'm starting to see things like EPDMs that have higher temperature capabilities, so that they can be used in place of some of the lower temperature materials. I'm also seeing, materials that are being used like for your oil drilling, gas drilling, deep hole drilling. Some of the materials that are being developed for those industries, very aggressive, very abusive environments. And as some of that technology continues to develop and transitions into the automotive industry and or just the general commercial industry, I think you're going to see some help with being able to do some things that we weren't able to do before with rubber parts. And then another big one is vehicle electrification or the hybrid technology. As more power plants are replaced by DC motors, that's going to mean fewer sealing components that are going to be required, fewer types of rubber parts. And the rubber industry is going to have to make some adjustments for the changes in the types of parts as well as the number of parts that are going to be required.
And how about the automation and artificial intelligence in the rubber molding companies now? What's happening in the US and other parts of the world?
Well, I think automation, the downside with automation is typically requires higher volumes to be able to justify being able to automate. And another potential disadvantage with automation is the fact that there are, as you continue to automate, there are more things in the system that can break down. So typically what I've seen as automation increases, the amount of uptime often will go down some. So your efficiency ratings will actually drop some. While you can certainly reduce your labor rates, but now sometimes those, The general laborers have to be replaced with more skilled technicians to be able to troubleshoot problems within the automation system and or to make improvements or updates to the programming of the equipment itself.
And you say there are maybe you can elaborate on what are the best practices in the rubber molding industry in USA, as you experience a lot. And I'd like to also have what can we learn from the big companies, to implement similar practices in the smaller and medium scale industry. There are the way their business run, large companies and small and medium scales are different. Okay, so but there is something we can gain, some expert knowledge and practices that can be implemented.
Okay. Well, and actually, one of the things that, with automation can certainly be a best practice. And it's not, when I was talking about there are certainly some potential drawback, that doesn't mean that it's not something that shouldn't be considered, but you need to take into account, some of the other potential changes that have to go with automation. As I was saying, you make sure you have the technical expertise either in-house or available fairly locally, so that if there is a problem with the system, that you can get yourself back up and running very quickly. I think something that COVID has shown, the world, is that lean manufacturing is not necessarily the best way to go. And I've, it's been my belief for years that, too lean is just as bad as not having any lean manufacturing. So finding that happy medium between, that just-in-time inventory and, having a whole warehouse full of parts so that you can run for a month, somewhere in between those two, I think is going to be, that ideal number. And it's probably not one or two, but like I said, it's probably not, having a whole month's worth of supply either. I also think, and again, this is something that COVID has, certainly brought to light. You need to look at having more than one source for your materials, for any of your outside services. If you're mixing your own rubber, that you have more than one potential source for the various ingredients that go into that rubber. And sometimes, one of the advantages a larger company has is the fact that they have the capability of being able to leverage buy larger volumes of ingredients, so that helps them reduce their raw material costs. Well, one of the ways a smaller company can overcome this is to work with, say, an outside rubber compounder, so that you can take advantage of their ability to leverage buy. Plus, you have a supplemental materials engineers that can work with your with the materials engineers that you have in-house. Or if you do not have a materials engineer, then you can go to somebody like a custom compounder to get that expertise to help you develop a material for whatever application that you might have.
Okay. I think, one I'd like to address one issue is about mold designs, and you also actually involved in the mold design for both plastics as well as the rubber. I know people always say designing mold for rubber products is much more challenging than the plastic products. What's your take on it?
Well, and I actually, when I started at Packard Electric, I actually started as a tool engineer for plastic parts as well as rubber parts. And then they transitioned me to becoming an an in-house support person for our outside rubber molder. So I have actually worked with both plastic as well as rubber rubber on plastic designs as well. The plastic it's a thermal plastic. It's an actual physical change that's happening to the material. You basically, you heat the plastic up, you put it into a cool to at most a warm mold, and as that after that plastic cavity has been filled and packed, it's losing temperature, so it's actually starting to want to shrink away from the walls of the cavity. With rubber, it's a thermoset, and it's a chemical reaction that's happening to the material. And because of this chemical, to initiate this chemical reaction, you need temperature to be able to start that. So I'm taking my rubber material that, like in the case of a compression mold, it's typically at room temperature. And even if I'm going to, say, an injection molding process, the rubber's going into the mold and, in a warm condition, and it's going into a hot mold. So anytime you take warm and increase the temperature, you get thermal expansion. So therefore, a rubber mold is much more prone to flash than a plastic mold. Now, I'm not saying you can't get flash on a plastic mold, but if a plastic mold is designed well and all the tolerances, are put together correctly, it's not too difficult to get a plastic mold to be flashless and the part to be flash free. It's much more difficult to do that with a rubber mold for the reasons that I was just talking about. You have that thermal expansion. So therefore, typically what happens is when you design a rubber mold, you know that you're going to have some flash, so you incorporate into the mold either ways of managing that flash with things like tear trims, dump grooves, overflow places for that excess rubber to go. And that has to be thought about during the actual design of the rubber mold. The other thing is that rubber is a forgiving material. I mean, it stretches, So typically, the part dimensions for a rubber part tend to have more generous tolerances. If they're designed correctly, they have more generous tolerances than a plastic part does. So typically, more precision is required to build a plastic mold that you typically want a little tighter fits, as well as tighter tolerances for the cavity portion of that mold. So therefore, the cost per cavity on a plastic mold is significantly higher than it is cost per cavity for a rubber mold. And because your rubber mold, because of this chemical reaction that we're talking about, it takes time for that to happen. Cycle times for rubber parts are significantly longer than cycle times for plastic parts. So typically with a plastic mold, I shouldn't say the mold is designed so that if I need 500,000 pieces a year, the mold will be built to make 500,000 plus a 25 or 35%, to allow for spikes in the requirements. Whereas a rubber mold, if I have say 150-ton press, and I can get 16 cavities in that press, I may only need 3 or 4 to meet the requirements, but because the cost per cavity is less, I will typically build, a higher number of cavities in a rubber mold. That helps reduce the piece cost. And being as the cost per cavity is less, you can justify the added cost. Now, exceptions to that would be materials like liquid silicone rubbers. They actually require tighter tolerances than even a plastic mold does, and their cost per cavity is even higher than a typical plastic mold would be.
There are, just to add to that mold design aspects, there are a number of rubber parts in automobile. In your opinion, which is most difficult among all the rubber parts, in automobile, in the cars, vehicles, which is the most difficult to design and produce, in your opinion?
What's the most expensive to design and produce?
Which is difficult to design and produce.
Well, and you're certainly correct in that typically the parts made for the automobile industry do tend to be more expensive. I think probably one of the more challenging parts to make, simply because of the thin walls that are required, would be something like a rubber diaphragm. Those typically require tighter tolerances, and because you're dealing with thinner walls, the material has to be mixed very well. Very little capability for those types of parts to manage material that hasn't been mixed and dispersed correctly, as well as the fact that the thinner walls just make it more of a challenge to be able to fill the cavity.
And just to add a little more on this subject, there are a lot of, as you rightly mentioned, about the complexities related to the rubber and the designing the molds for it. Do you have any suggestions, for the rubber mold designers, what are the things they to be careful when they design to save their time and cost? Yeah. In terms of designing the molds.
One of the things that I've always talked about when I'm talking about design for manufacturability is wall thicknesses and radiuses. Rubber does not like to flow around corners. So with the exception of where that part is actually at a parting line in the mold, you want to have as generous a radius as possible. The other thing is as I was just mentioning, wall thicknesses. Some materials such as silicones and liquid silicones flow fairly easily, so you can manage with thinner wall sections. But when you start getting into higher viscosity materials, like for instance, fluorocarbons, Vitons, fluoroelastomer, whatever name you want to use for them, they have a specific gravity of between 1.8 and 2.1 for a typical fluorocarbon. Those materials do not flow very well. They do not like thin walls. And even some of the more moldable, lower viscosity, organic rubbers like EPDMs, SBRs, natural rubbers, there is still, it's better if you can get a wall thickness that's at least, like, say, a 1.25 or 1.5 is kind of a minimum thickness. And depending on the length of that wall, you may need to even go a little bit thicker than that. So, my two big recommendations is watch the wall thickness, as well as, no sharp corners. I like to see a minimum of a 0.8. If I can get like a 1.5 or a 2 millimeter radius, that's even better. Certainly there are applications where I've seen, a 0.1 or a 0.25 radius. If that's what's required for the product, then it has to be that. But it's going to make it more difficult to mold. And as I was mentioning, for some materials, it'll be more of a challenge than for other materials.
Thank you, Terry. Terry, I think with your experience, you found that estimating the cost of the molded rubber parts is very important. I think it's for every manufacturer, they had to estimate the cost. You have developed a very interesting and useful tool for the rubber molding industry. We call it Chapin molded rubber parts cost calculator. Can you talk more about it? What was the initiative behind it, and how it is useful for the rubber mold manufacturers?
The whole cost management team at Delphi was started probably close to 15 years ago now. Our director actually came from Honda. And, the idea behind it was, we understand, profit's not a dirty word, but excess profit is certainly not good if you're the person buying the part. It's great if you're the person selling the part. So the idea behind it was, let's come up with a tool that will allow us to pay a fair price, so that the supplier of the rubber part is making a reasonable profit, and we're getting the part for a reasonable price. So what happened was and Excel spreadsheets were developed for various parts that we were purchasing, and I was involved with the team that initially generated the Excel spreadsheet to calculate what we should be paying for a rubber part. And then, after I left Delphi, I removed I removed the proprietary information that was, in that model. And then, and we'll talk a little bit more about this later on in the training class that I developed for estimating the cost of rubber parts. I show locations, show how to get the cost for the various materials, the various cost centers, your raw material, your labor, your burden rate, as well as what to expect for a reasonable profit margin, for various types of suppliers. There were several days, actually weeks, that were spent originally developing the Excel spreadsheet, and it's continued to be refined. I've continued to make changes and updates and improvements to it, as I continue to use it. And that is something, I'm very proud of the fact that, it's not just something that I did and handed it off to somebody else and said, here, use it. I mean, I use it myself. And as I see things that could be improved, I make improvements to that spreadsheet. With good input, I can typically get within 3 to 5% of the actual part cost. And even with making some estimates, and the more familiar I am with the manufacturing of the particular part, the closer I can actually get to the actual part cost, even by making some assumptions as to how that part's going to be made. There is even a portion of that cost calculator that, if when you input a certain press size and put the part dimensions in, it'll generate an estimated number of cavities that will be in that rubber mold when it's built.
It's a very good tool, that. Terry, you've been associated with the TechnoBiz for quite a while, number of years, and also we started doing a lot of webinars for the KnowHow webinars. So what is your impression overall with your working relation with the TechnoBiz and KnowHow webinar project?
Well, as you mentioned, Param, it's hard to believe that it's been almost 10 years since I started working with TechnoBiz in the United States, and then of course that led to me meeting you and working with you, so taking it to the global nature. I think there are several good topics that that are covered through the TechnoBiz webinars. And certainly not just the ones that I bring to TechnoBiz. As you had mentioned a little bit earlier, you have a lot of experts that you can pull their expertise from. I certainly don't claim to know everything about rubber molding. I can say that I've been exposed to a lot, and I think that allows me to bring more topics to TechnoBiz for these KnowHow webinars. This is based on my experience, my observations, my work. A lot of this, the information that I share is things that I've learned by actually doing. I mean, it's I don't just teach. I mean, well, I do now, but I mean, what I'm teaching is stuff that I've learned by actually working with making rubber parts and working with other suppliers that are making rubber parts. So overall, I think we've had a good relationship, between, myself, my company, Elastomeister, and TechnoBiz. As I had mentioned earlier, I enjoy teaching, I enjoy training, I enjoy passing on some of the knowledge, that I've learned, so that other people don't have to learn it the hard way. one of the jokes that I make is that, one of my references is, Terry's School of Hard Knocks. What I'm doing is I'm sharing things, okay, I know this works because I tried it, or I know this doesn't work because, I tried it and it didn't work. So, and like I said, I like to share that information so that other people don't have to learn the hard way. And there's certainly nothing wrong with making mistakes as long as you learn from them. But that I think the saying goes, it's a wise man that can learn from somebody else's mistakes, and hopefully that's what I'm doing, is by passing on some knowledge that I've learned because of some mistakes I've made, or seeing mistakes that other people have made, or that we've made. If it's been more than one person, and then passing that experience on, so that I think it's a benefit to anybody that attends any one of the TechnoBiz KnowHow webinars, and that's true whether it's something that I'm presenting or one of the other experts that are working with TechnoBiz.
Very nice. Thank you, Terry. It's always, a pleasure to work with you, and also, having you on board as one of our experts for the KnowHow webinar. Not only, we did lots of physical programs over many years. Because of the COVID, we started this KnowHow webinars, and thank you all being your support and contribution. I think it's a time for you to, explain all your webinars, what kind of webinars you're contributor, and what it means for the audience, what kind of content is there, how it is beneficial, who benefits out of this webinar. Now, let's go with one by one.
Okay.
Yeah. The first topic.
Cost estimating for molded rubber parts. And as we were just talking about the cost estimator that I had developed, that is actually what I'm showing you how to use in this actual webinar. We start talking about what is needed to estimate the cost of a part. What are the elements that you need to be able to plug into this cost calculator so you can come up with an answer. We look at the various processes that are involved to make a rubber part, because all of those add costs, to the actual making of that part, and those have to be captured within that cost estimator. Things like material information, or cost for the material, which is probably one of the harder pieces of information to get. For some materials like natural rubbers and some SBRs, there is some data available, and in some cases it's a matter of actually working with like rubber compounders to get an idea of what the estimated cost would be for certain types of materials. Also talk about and differentiate between engineered waste versus scrap. Scrap is bad parts. Engineered waste is the material that's needed to make the part, but that doesn't actually go into the part. Talk about the machine and overhead costs, what typical profit margins are going to be. And as I already mentioned, it does include a copy of of my rubber parts cost calculator, which, as I had mentioned a little bit earlier, there's a lot of time that went into developing and refining that cost model. And that's something that I can use today. In this training, I actually include 3 examples, and and how those how that information gets put into the cost calculator, and detailed instructions on how to use the cost calculator. My wife is also an engineer, but she's not involved with rubber. I actually gave her the examples and the instructions and asked her to follow the instructions, and she found a couple of things, so that I made some actual changes to the instructions, so that if you're not real familiar with using Excel, or the actual process for making a rubber part, if you get these pieces of information and follow the directions, you'll be able to put that information into that cost calculator and come up with an estimated cost for that part.
I think this is you are the only one who offered this topic, I guess, in the world. Is it correct, Terry?
There's very few people that have the capability of estimating rubber parts. There's actually there is a cost leader group out there right now, but to my knowledge, I'm like you said, I'm still the only one that's been involved with for rubber parts, and they are definitely different than the other types of parts to make.
Yes, super. Let's get to the second topic of yours. Yeah.
This is rubber product molding and process overview for the non-technologist. I like to call this Rubber 101. And what it is it's a basic overview of rubber molding. You got somebody that's new to the rubber industry, or maybe somebody that is like say maybe in sales, so that doesn't need to know exactly how to make a rubber part, but it would help if he understood a little bit more about what was involved. This is the type of class that would be very good for them, because I do touch on the various rubber molding methods, an overview of presses and molding equipment, what's involved with processing of rubber. I also touch on some of the, besides the traditional compression, transfer, and injection, I also touch on some of the other types of rubber molding, like liquid silicone rubber, polyurethane or rim reaction injection molding, liquid silicone. I touch on all of the, and emphasis is on touch. We don't do a deep dive into any of these types of molding processes, because it is meant to be an overview to give somebody a general idea of what's involved with in the rubber industry. Also take a look at system considerations, like what's involved in a part design, little things like parting lines and gates, and how the different types of molding will influence the equipment that's being used, as well as press size and style of press.
And it's also useful for the people who want to invest in the rubber product industry and see what other things, elements are involved. Yeah.
Right.
Let's talk to the third one. Yeah.
Okay, rubber molding using vacuum theory in practice. And as this course indicates, I mean, it's looking at, what does it take to apply vacuum to a rubber mold? What are the objectives? Why are you putting vacuum on a mold? What are the advantages of vacuum molding? And how do you do a vacuum? Compression molding has some different requirements for tool design than does transfer or an injection molding. We talk about what those differences are and how you can still achieve vacuum with compression molding. It is a little bit more difficult than it is with transfer or injection molding. Not saying that it's easy to vacuum on those, but it's a little bit easier. And we talk about how do you seal a vacuum mold, materials that are best used for sealing a vacuum mold, as well as we talk about vacuum presses versus the difference between them versus just vacuum on the mold itself. And another important one is, while vacuum is supposed to remove the air from the mold, if there's some air in the material or there's byproducts from like adhesives or from the cure system, those still need to come out of the cavity. So we talk about, even after the mold's been closed. So we talk about how do you vent that vacuum mold so that those residual byproducts can be pulled out of the cavity so that they don't interfere with the curing and or flowing of the material, and so that you get a good part.
Thank you. Let's go to the next topic.
Selection of the molding process for rubber parts. And this particular webinar, I take a look at various types of rubber parts and what would be the typical molding processes that would be used, whether we're talking about low volume versus high volume options. And just basically, it's a step-by-step. Okay, if I have a conveyor belt, what type of molding method? If I'm molding a grommet, which molding methods? High volume, low volume, and just actually step through the various types of parts and what would be the recommended method. For a lot of the parts, there isn't one right way to mold a part. Some of that depends on labor costs, region that you're in. If you're in high cost regions, you may look to something that's a little bit more automated or semi-automated, or at least gives you a higher output. And we look at all of that when we're looking at selecting the molding process for rubber parts. Mold releases, platings, and coatings for rubber molding. This actually, I had, after I had one of my training classes, I had a couple of my students, quote unquote students, come to me and ask me if I knew anything about, if I could come to their company and talk about mold releases for their parts, and they didn't want a salesman to come in from one of the various mold release companies and give them a sales pitch on their product. They wanted more of a an unbiased third party opinion. And the reason they'd asked for this is because they had gotten to the point where they were using several different mold releases, and they were looking at trying to combine some of these, so that they could, so they didn't have to have so many different mold releases, in-house. So we actually take a look at the various mold release types, the application techniques, frequency of application depending on which type of coating, as well as factors to consider when selecting a mold release. In addition to mold releases, we also talk about mold platings and coatings, because another way to keep the parts from sticking or to make the parts easier to release is to go to something that is more permanent, like a mold plating or a mold coating. I also include some real mold release results. I talked with some of the customers, some of the suppliers I had dealt with before. I work with Ben Walworth, who is another expert that has several presentations on TechnoBiz, several KnowHow webinars. But we looked at some of the stuff, some of our experiences, what we had seen work. All that was incorporated into this real world results for mold releases and platings. And then as a conclusion to this, I actually have what I call a recommendation for the recommended steps to follow to get a good and appropriate part release.
Okay, next one.
Okay, basic rubber product material selection overview. This webinar here, I actually start talking about, what are some of the difference between your silicone rubbers versus the organic rubber materials, and then go about looking at how do you determine which rubber, which elastomer you select by looking at the various rubber material properties, go through a protocol for selecting a rubber material. And then in addition to that, not only do you want to have a material that will work for the application, but you also have to have a material that is moldable, that is processable. And so then we look at a little bit at the rubber material flow and some tools for determining rubber material flow. You can have a great material for the application, but if you can't process it then it doesn't do you any good. And so in conjunction with, looking at the material, also look at some testing methods for evaluating rubber flow and testing of the mixed rubber compounds themselves. Rubber part tolerances. We talked a little bit earlier, I had mentioned about design for manufacturability, and this would be actually another recommendation for somebody that is designing a rubber part is don't, to specify a tighter tolerance than is absolutely necessary. Because that doesn't increase cost for the rubber part. A lot of times it will increase scrap. So in this class, I talk about, why do we need tolerance recommendation? Why do we need various tolerances? We talk about factors that affect the tolerances, including things like inserts, shrinkage variation, how mold design or the type of mold, compression versus transfer versus injection, can impact, the way the part fills, packs, and the shrinkage numbers. Also review, in the United States, we have the Rubber Manufacturers Association. Well, it is now ARPM, Association of Rubber Parts Manufacturers. It started out as the RMA, but the RMA split and became tire oriented, just strictly tire oriented, and the ARPM split off to do the molded parts. But it started as the RMA tables, and now it's the ARPM tolerance tables. And then, as I had mentioned, what are some of the costs associated with tolerances that are tighter than necessary? And then I actually make some tolerance recommendations, based on my experiences, some capability studies that I did on some of the rubber parts, that I built tooling for. Rubber mold debug. It's one thing to have, to build a mold, put it in production, but then, what happens, once it's in production and you start having problems. And actually the first step of that is during the actual debug or qualification of the mold itself. But we look at prototype versus a development tool. And I personally prefer development mold, and I explain why in this class. Talk about some more about design for manufacturability and or moldability. Something that would help, it will help if you're designing parts. Why do we need some of these things? And we touch on some of this during the rubber mold debug, as well as the rubber part tolerances. There is some overlap between those two classes. We talk about rubber adhesion. Some things to help get with rubber, to get rubber to stick to the insert, be they plastic or metal, ways of testing for rubber adhesion. Also talk about bonding rubber to plastic, which is becoming much more common than it used to be. Gates and venting. A lot of times I can help reduce air trap problems by either adding vents or putting vents in the proper locations, as well as gates. And then some other potential solutions. Some of those may involve some changes to the materials themselves to help with making good rubber parts and reducing, ideally eliminating the molding defects. Deflashing techniques in the rubber molding process. And this is where we just take a look at, how do you get the flash off of rubber parts? We look at both hand deflashing methods, automated or semi-automated deflashing methods, as well as cryogenic and non-cryogenic deflashing methods, and just take a look at all of these different types of processes, and so that you have a better understanding of which one or which ones would work best for the types of parts that you're molding. A compression rubber molding, and this is a master class. This is going to be it's going to be at least 8, possibly even 8.5 hours long. There'll be an overview of the compression rubber molding process, the types of presses that are used for compression molding. We'll talk about the deflashing methods, principles of mold construction, what's involved with actually building a rubber mold, which will include things like cavity layouts, mold steels and mold finishes, that are recommended, mold registrations, leader pin bushings, cavity inserts, when should you have cavity inserts, why would you have cavity inserts, mold parting lines, tear trims and overflows, which to a certain extent ties in with deflashing methods as well. We'll talk about something that Van Walworth and I developed together called pulse filling. Preform shape can be very important, very critical for getting good rubber parts, and we'll talk about some of the requirements for preforms. Look at venting options, platens, mold mounting, mold insulation, as well as in this class here, we will talk about vacuum molding specifically for compression molding. And then last and probably most important is this class will include process troubleshooting, which includes troubleshooting charts. Now, we won't be able to go through all of the charts, but we'll talk about the basic troubleshooting, and we'll probably review 1 or 2 molding defects and how to actually use the charts. And then that class will include the various types of typical molding problems and the troubleshooting methods that you can use to help resolve those problems. As I had just touched on it, with compression molding, pulse filling for improved rubber molding performance. And pulse filling is different from your typical clamping or your typical injection process. We also look at a pressure bump versus a gap bump for helping reduce or eliminating air in the cavities. And then as well as incorporating pulse filling with pressure bumps. We look at measuring rubber force displacement, and this goes to show you why the pulse filling actually can help you reduce your cavity filling and packing problem, as well as some pulse filling examples and the benefits of pulse filling. Balancing the fill of cavities in rubber injection molding. It's a known problem in both the plastic as well as the rubber industry that, cavity filling, even though it's geometrically balanced, is not necessarily flow balanced. And this is something else that Van Walworth and I work together on. Van and I have been teaching together for about the same 30 years that I've been involved with teaching in the rubber industry. So we've worked together, on a fairly regular basis, and have developed some techniques, together, or at least, brainstorm with each other on various ideas. But Van actually developed what he calls this Venturi, and we came up with some studies to show how this helps to balance the flow of and filling of the cavities much more uniformly. Even though the cavities may be geometrically balanced, we show in this study that even though they are geometrically balanced, that they're not flow balanced. And then by adding the Venturi, you get pretty uniform filling. And we show some of the studies and show the improvement by having that Venturi added to balance that cavity fill. So then the next topic is microventing, and this is used to eliminate gassing or air entrapment in rubber molding. And we start by defining, what is gassing? What is it? What are some of the potential solutions and some of the problems with some of the past solutions for eliminating the gas? We look at the application, the products, the molding methods. We look at something called, and so our solution, which helps eliminate some of the problems with some of the other solutions, is what we call microventing. We talk about some of the costs, some of the potential drawbacks with microventing, as well as some results and a summary of what microventing is. Sealing of transfer pots and applications in rubber molding. And this is actually one that I'm in the process of finishing up right now, but we're reviewing the various methods and materials for sealing transfer pots. And some of these may be temporary, as in maybe you have an older mold where the pot and piston are worn and you're getting some leakage. We look at some temporary solutions for those types of problems, as well as some permanent methods for sealing the pot to the piston. We also discuss bottomless pots and some of the benefits of having a bottomless pot.
Yeah, thank you. That's currently what we have for your webinars, and maybe it's give you some wonderful message to the potential participants or the past and present participants of your webinar.
Well, first, Param, I'd like to thank you and TechnoBiz for hosting these webinars. Like I was saying, I think it's an excellent tool for being able to pass on, not just my knowledge, but all the other experts that you've been able to gather to put together these various webinars. I want to thank everybody for watching this interview, and hopefully you have a better understanding of which classes would benefit you and which webinars are going to be the next ones that you're going to want to attend. I want to thank everybody that has attended one of my webinars or is planning on attending one of my webinars in the future, as well as the other webinars that Param has available. I think you will find the information presented in the webinars to be helpful. As I had mentioned earlier, some of this information is stuff that I've learned and or developed or done research to be able to present to you. And hopefully we'll be able to see you face to face at a future webinar or forum as we get behind this whole COVID scenario here.
Yes, that's right. Thank you. Thank you, Terry. Guys, as you see from this talk with Terry, you definitely have a better understanding about his expertise and experience over the years, and what kind of topics is been contributing for the KnowHow webinars, how is it beneficial to. I think it's very good topics, probably very unique topics for the rubber molding, particularly the rubber molding industry. Terry is a very much specialized. We really have, grateful and thankful to Terry to being part of our, educational program through the KnowHow webinars. And I'd like to give some more information, to the audience about how you can benefit out of the KnowHow webinars. We have, the KnowHow webinar memberships. Okay, basically it's better to be a member as we continuously developing various topics. For the rubber industry itself, we have close to 150 topics now, but that's not the end. We keep on adding. Terry will be adding more as you see that what is relevant to the industry. So we're inviting like the friend like Van Walworth, many others. So we are much grateful to all these people who are willing to contribute, which benefits particularly the younger generation to learn about skills. And so I'll give you what are the memberships available for the through the KnowHow webinar. See, these are specialized professional education programs and with the global experts focusing on the current trends and the needs. That's all about it. And most important about why I ask you to be the member is basically we focus on the quality. It's very important to have quality learning and also the professional education. And the benefit of being a member of KnowHow webinar is that you associate with huge resources with all the experts from the different parts of the world. Here you can see, these are not the end. There are some of many people are coming in, and so they're all global, international, and well experienced. Everybody has a minimum 25 years industry experience exposure, and some of them have close to 65 years experience. So they got huge knowledge, and if I combine together, I don't know how many thousands of experience there, but the point is that we are bringing a huge pool of experts together and providing knowledge-based programs that are relevant to the industry. Okay, it's not what currently they need, what skills are required for the young people, and also the professionals involved in the industry. They all are highly knowledgeable. And you can check all the list of topics, and I can't put together all in now here, what topics are available. This program is focusing on the terrorist topics. We already have 14, there will be more in the future. Like this, we have many topics there. You can check the details in our website, knowhow-webinars.com. And what kind of memberships we offer? See, so we have, you can become a professional member as an individual. You can become a corporate member. We also offer education student membership, which so that they can use this educational tools for the students and researchers in universities and the colleges. And also we have premium scale, which means that you can join anything you want out of this KnowHow webinars. Premium professional member and also premium corporate member. So our subscription system is yearly basis. It's a fee base, it's a yearly basis. So if you're interested to know about this KnowHow webinars membership, you can check this link and what are the costs, fees, structure, so you can register online. Okay, any information you need on the KnowHow webinars, any other things. TechnoBiz is a very unique organization that offers knowledge is one of the primary pillar of the TechnoBiz business. So if you need some information assistance, here is my contact. You can reach out to me by email or WhatsApp or by mobile call or through our website. Okay? So that's briefly about KnowHow webinars. And then Terry, before we end this program, we'd like to have a final message to the audience.
Just again, thank you, Param, and thank everybody for attending. And hopefully you will have learned which of my various KnowHow webinars will be beneficial to you.
Thank you very much, Terry. Thank you very much for contributing for this session. I look forward to talking to you soon. Thank you all. Bye-bye for now.
Bye now.